Implicit differentiation. What is implicit differentiation? It is a method in calculus that we need to use for us to find the derivative of implicit functions. Now, you're probably wondering what it even means for a function to be called implicit. Well, the word implicit is the opposite of explicit, and the word explicit basically means clearly defined or expressed. So, explicit functions are the ones we've already seen a lot in our calculus class. It looked like this. A dependent variable, in most cases we call this as y, while expressed as the function of an independent variable, usually called as x. These types of functions can be differentiated using our usual methods without any trouble. But if the function is not explicit, that is, if y is not clearly expressed as a function of x, we call it an explicit function. Implicit functions look like this. X's and y's are tangled up together in such a way that they are not easily separated. In this function, for example, we can try to isolate the variables a couple of different ways, but it just doesn't work. This is where implicit differentiation comes into play. Let's go ahead and use it to differentiate this function. The first thing we'll do is to take the derivative of both sides with respect to x. So let's write the derivative of x squared plus y squared with respect to x is equal to the derivative of 12 with respect to x. Notice that the right side of the equation is constant, and just like always, the derivative of constant will always be 0. So let's scratch out this derivative of 12, which is 0. And then on the left side, we'll need to take the derivative of both components of x squared plus y squared. So the derivative of x squared with respect to x plus the derivative of y squared with respect to x is equal to 0. So we notice that the x squared component is easy to differentiate. So we just use the power rule. So 1x squared minus 1 is equal to 2x, while the y squared is 2y. So the derivative of x squared is 2x plus 2y. And then we need to multiply this term by dy over dx, which is equal to 0. And then, so now let's bring down first the 2y, which is multiplied by dy over dx. So you can see that we end up with the derivative we got using implicit differentiation. So implicit differentiation is just glorified application of the chain rule. So we notice that we write on the left side, or the first, is the 2y with the derivative of y with respect to x is equal to negative 2x. So as usual, if we move a variable or numbers into an equal sign, it will become negative or positive, or it will change the sign. Before we start, let's all review the chain rule formula, because we'll know that to understand implicit differentiation, we must have a good understanding of the chain rule. Chain rule is a formula that expresses the derivative of two differentiable functions, the f and g, in terms of the derivatives of f and g. So here is the explanation. So we see here as the formula of chain rule, the derivative of a composite function is equal to the derivative of the outer function. So we notice that the derivative of g of x is derivative of inner function, that is our inner function. And while the composite function is probably equal to, again, is probably equal to f prime g of x, which is the derivative of outer function. So these two variables are representing the chain rule formula. So for example is we have here we will now have our example. We were going to use the chain rule formula. So the derivative of f of g of x with respect to x is equal to the derivative of 3x plus 1 squared with respect to x. So we need to differentiate these functions. So first is we need to differentiate the outer function, which is 2, and then copy the inner function, which is 3x plus 1, and then times the derivative of 3x plus 1, the inner function, which is, by differentiating 3x plus 1, we need to cancel out the 1 because we know that constant number is probably equal to 0. Then 3, because 3 times 1 is 3. And then let's multiply these functions into by distributing this. So 2 times 3 times 3 is equal to, copy the 2 first, and 9x plus 1 times 3 is positive 3. So now after that, let's differentiate, or let's continue to multiply it with the inner function. So 2 times 9x is equal to 18x. 2 times 3 is equal to positive 6. So this is our final answer. So that's how chain rule formula work in differentiating this function. So that's our final answer. The derivative of y with respect to x is equal to 18x plus 6. So here we move for our second example, which is the derivative of 4 squared plus x cubed with respect to x. Now, let's differentiate these functions with the use, again, we need to use the chain rule. So first, we need to differentiate the outer function. So the outer function is the 3. So the derivative of f of g of x with respect to x is equal to f prime g of x times g prime of x. So that is the formula. So we have to write first the formula. So for our f prime, which is the outer function, so we have u cubed. So the derivative of u cubed is equal to 3u squared. It is because, let's bring down the 3. So 3, then minus 1. 3 minus 1 is definitely 2. And then for our inside function is the g of x, which is 4x squared plus x. So we need to differentiate the g of x, g prime of x, So by differentiating this is, we have to multiply the 4x squared. We need to use the power or the exponential rule. So 4 times 2 is equal to 8x. And then 2 minus 1 is definitely 1. Then the derivative of x is definitely 1. So now let's substitute the derivative of f of g of x into the inner function, which is 4 squared plus x raised to 3. So that's it. Then equal to f prime g of x times g prime of x So here we were going to use the chain rule. So the f prime g of x is definitely the inside function, which is the 4x squared plus x. So as we notice that it is not cube, it becomes squared because 3 minus 1 is 2. Then multiply it with the g of x, g prime of x, which is 8x plus 1. So let's bring down the 8x plus 1. So we see here that the 4x squared plus x is squared. So we have to split the functions and it will become 2 functions because it is squared. So now by splitting this function is, let's write 2 function. Then so 4x squared plus x times 4x squared plus x. So let's multiply these 2 functions. So now by multiplying this is we have to distribute the or multiply 4x squared times 4x squared. So it is 16x raised to 4. Then 4x squared times x is 4x cubed plus x times 4x squared is equal to 4x cubed plus x squared. So after that is so we notice that we have the same function or the same variables and numbers. So 16x raised to 4 plus 8x cubed because we added the 2, which is 4x cubed plus 4x cubed. So 8x cubed plus x squared. So that's the derivative of 4x squared plus x raised to 3. But somehow that is not our final answer. We have to simplify this function. So by simplifying this is we have to rewrite the derivative of 4x squared plus x raised to cube. Then so simplify. So we need to write the formula. So the derivative of 4x squared plus x raised to cube with respect to x is equal to, so for our f prime g of x is we have 3, but the squared 4x squared plus x is we have to substitute it because we already differentiate that function. So now let's write the function of f prime g of x, which is, so now let's write the 16x raised to 4 plus 8x cubed plus x squared. So we need to use the formula again. So f prime g of x is we have bring down the 3. Yes, we have to bring down the 3. So then that's it. Again, bring down the 3, open parentheses. So 16x raised to 4 plus 8x cubed plus x squared. So times the g prime of x, which is 8x plus 1. So let's bring down the 8x plus 1. So we need to multiply the 16x raised to 4 to 8x so that we can differentiate these functions. We have to multiply it into every variable and every numbers. So now copy the 3. 16x raised to 4 times 8x is equal to 128x raised to 5. So 16x raised to 4 times 1, so plus 16x raised to 4. So now 8x cubed plus times 8x, so plus 64x 4 or raised to 4. Then 8x cubed times 1, so plus 8x cubed plus x squared multiplied by 8x, so it is equal to 8x cubed plus x squared. So after this is we have to multiply it with 3. We have to multiply it to their common variable and common numbers. So we notice that 16x raised to 4 and plus 64x raised to 4 is the same. So let's write the 3 times, or let's bring down the 128x raised to 5. So we have to add the 16x raised to 4 plus 64x raised to 4. So it will equal to 80x raised to 4. So and then we have to add the 8x cubed plus 8x cubed. So will equal to positive 16x cubed plus x squared. So now let's multiply it with 3. So 3 times 128x raised to 5 is equal to 384x raised to 5. Then 3 times 80x raised to 4 is equal to positive 240x raised to 4. And then 3 times 16x cubed is 48x cubed. And then 3 times x squared is 3x squared. So this function, while differentiating this function, is we have the answer, which is the derivative of y with respect to x is equal to 384x raised to 5 plus 240x raised to 4 plus 48x cubed plus 3x squared. That is our final answer. So for our third example is find the derivative of y with respect to x of the equation x squared plus y squared is equal to 100. So now let's bring down the x squared plus y squared is equal to 100. So the derivative of x squared plus y squared equals 100 with respect to x is we have to split this. We have to differentiate this. First is the x squared, which is the derivative of x squared is 2x because 1 times 2 is 2, then minus 1 is 1. So 2x, so the derivative of y squared is 2y because 1 times 2 is 2 and then 2 minus 1 is y. Then multiplied it with dy over dx, which is equal to 0 because constant is definitely 0. So 2x, so we have to put the 2x after the equal sign. So if we put it in after the equal sign, definitely the sign will become negative. So 2y times the derivative of y with respect to x is equal to negative 2x. So now we notice that it is negative 2x now because we put it in the right side after the equal sign. So let's over it with 2y. So cancel the 2's. So the derivative of y with respect to x is equal to negative x over y. So that's our final answer for today. So we notice that there are different functions or inside functions where we need to differentiate these functions. So here we have the derivative of x cubed with respect to x, and then the second one is the derivative of y cubed with respect to x, and then the third one is the derivative of r raised to 4 with respect to x. So just always remember that every time you differentiate a y variable, you need to add the term, the derivative of y with respect to x. Moreover, you can also apply the rules in derivative, the chain rule, the product rule, the power rule, the quotient rule, and so on. So let's start to differentiate the first example, which is the derivative of x cubed with respect to x. So differentiating this, 3x squared times the derivative of x with respect to x. So the second one is the derivative of y cubed with respect to x. So while differentiating this is, we will have the answer, which is 3y squared, because 1 times 3 is 3 and 3 minus 1 is 2. So the answer is that. So, and then the third one is to differentiate the derivative of r raised to 4. So the answer is 4r cubed, because 1 times 4 is 4 and 3 minus 1 is, 4 minus 1 is 3. So this is the differentiated functions, the answers. And again, always remember that every time you differentiate a y variable or any variables, you need to add the derivative of y with respect to x, or the derivative of dr with respect to x, and so on. Now, let's differentiate example problems using implicit differentiation. So first is, we have find the derivative of y with respect to x of cosine x squared plus sine y cubed equals to 6. So by differentiating these functions is, we need to copy the equation. Then cosine x squared plus sine y cubed is equal to 6. So we have to split these functions, or we have to put dy over dx, or we have to multiply it with the derivative of y over dx for us to differentiate this function. So the derivative of cos is negative sine x squared times the derivative of inside function, which is 2x, and then the derivative of sine is cos, copy the y cubed, then the derivative of the inside function, which is 3y squared. 3y squared come from y cubed. Multiply it with the derivative of y with respect to x is equal to 0, because 6 is constant, and then constant number is definitely 0. And then copy or bring down the 3y squared times the derivative of y over dx. But first, multiply it with the cosine y cubed. So the answer is 3y squared times cos y cubed with the respect of the derivative of y with respect to x. So equals to the negative sign of sine is, it will become 2 positive, then multiply the 2x into negative sine x squared. Then the sign it will become positive, so 2x times the negative sine x squared, which is, it will become positive sine x squared, over it with 3y squared cos y cubed on the right side and on the left side, for us to cancel out the terms or the common functions. So then we can cancel out these two functions, and then copy the derivative of y with respect to x is equal to 2x sine x squared all over 3y squared cosine y cubed. So this is our final answer. That's it. Moving forward for our second example, which is find the derivative of y with respect to x if x cubed plus y cubed is equal to 6xy. So again, let's multiply it with the derivative of each terms. So first, copy the equation, which is the x cubed plus y cubed is equal to 6xy. And then let's differentiate or these terms. So copy the derivative of x cubed with respect to x plus the derivative of y cubed with respect to x is equal to the derivative 6xy. So by this, we need to separate this inside functions, which is x cubed plus y cubed, because these variables are different, so we have to differentiate into different sides or different column. So the derivative of x cubed, we need to write it before we differentiate, but into a split way or form. So that's it. So you can see here the derivative of x cubed over dx, and also the derivative of y cubed times the dy with the over dx, then the 6x, the derivative of y with respect of x. So we can notice that the 6x is multiplied by 6y, and then after this is we need to differentiate the x cubed. So the derivative of x cubed is definitely 3x squared. Then the derivative of y cubed is definitely 3y squared, and then multiply it with the derivative of y with respect to the x, then equal to derivative of 6x with the respect of x plus 6y. So then after that, let's bring down the 3x squared plus 3y squared with the respect, with times the derivative of y with the respect of x, or with the respect to x. If we try to distribute the 6x times the derivative of y over dx here, and after the equal sign, it will become negative 6x with the times dy over dx, then equal to 6y minus 3x squared, because we put the 3x squared before the equal sign. So we know that if the position is changed, and then the sign, it will also change. And then let's copy the derivative of y over dx, or the derivative of y with respect to x, and then bring down the 3y squared minus 6x, then equal to 6y minus 3x squared. Then to cancel out 3y squared over, minus 6x is we have to over it with 3y squared minus 6x2, the both side, right and the left side. So after this is we can cancel out the 3y squared minus 6x. So let's bring down the derivative of y with respect to x. dy over dx is equal to 6y minus 3x squared all over 3y squared minus 6x. So we notice that there is a greatest common factor of these functions or variables or numbers. So the greatest common factors is 3. So now can cancel this 6 and it will become 2y, and then cancel this 3 and it will become x squared all over, cancel the 3 here in the denominator, which will become 3y squared, cancel out the 6 and it will become 2x. So that's our final answer. So the derivative of y with respect to x is equal to 2y minus x squared all over y squared minus 2x. The third problem, find the derivative of y over dx if 5xy minus y cubed is equal to 8. So first bring down the equation or the problem, and the equation is 5xy minus y cubed is equal to 8. And then let's differentiate this. So 5x and 5y is different. There is a two variable in that one function or one number, which is 5. So 5y plus 5x times 1 with the derivative of y with respect to x minus 3y squared, which is the derivative of y cubed. And then with the times the derivative of y with respect to x equal to 0 because the constant 8 is probably 0. And then copy the function, which is 5x times the derivative of y with respect to x minus 3y squared. So let's bring down the negative 3y squared times the derivative of y with respect to x. And then it is equal to negative 5y. As we notice that the sign changed because we transfer it into the right side. And then after this is we need to over it to cancel out 5x minus 3y squared. So let's put over it with 5x minus 3y squared, the right side and on the left side. Then cancel this 5x minus 3y squared. So the derivative of y with respect to x is equal to negative 5y all over 5x minus 3y squared. So this is our final answer. And for the last problem, find the derivative of y with respect to x if x squared plus 2xy plus y squared is equal to 5. So now let's copy the equation. So now let's differentiate these functions. And then differentiating x squared is the derivative of x squared is 2x plus the derivative of 2 with the variables which is x and y. We have to split the 2. So 2 times y plus 2x 1 times the derivative of y with respect to x plus 2y, which is the derivative of y squared, is equal to 0. Because the constant 5 is definitely 0. So now let's bring down the 2x times the derivative of y over dx plus the 2y times the derivative of y over dx, and then equals to negative 2x, because as we know, if the position is changed, especially when there is an equal sign, so the sign will change, will become negative, and also for the not only the 2x but also the 2y. And then after this is we can see that we can cancel the 2's, and then copy the derivative of y over dx, then copy the x plus y is equal to negative 1 times x plus y. So for us to cancel out is we have to write, or we have to over it with x plus y cancelled. And after this is we only left out with the derivative of y with respect to x is equal to negative 1. That's our final answer.